Cathode-Ray Oscilloscope, Part 2. In the first video, we discussed about the basics of CRO, how the electron beam is made to accelerate, how the traces are formed, and how to measure the voltage of both AC and DC, and how to find out the frequency. This was all discussed in the previous video, but we did not discuss few points related to the Y gain setting and time-based setting. What will be the effect on the appearance of the trace when the setting is changed for particular voltage or particular frequency. In the same way, we did not talk about the grid, which will change the brightness of the spot or trace. So this is to be discussed in this video. So first, let us see the screen of the CRO. This has 100 squares, and the square has height 1 centimeter and length also 1 centimeter. It means area of one square is 1 centimeter square. And there are further subdivisions. And how many subdivisions are there? There are 5 subdivisions. It means in height of 1 centimeter or width of 1 centimeter, there are 5 subdivisions, and length of each division is 0.2 centimeter. And what will be the value? That all depends upon the setting. So first we will start with voltage and Y gain setting. How to measure the voltage and what will happen to the trace when the voltage setting is changed. So right now nothing is connected to Y and X plates. So spot is appearing in the middle, but I want to see the line. So what should I do? Oh, I forgot to turn the time base on. So when time base is on, the spot changes into horizontal line. It means the beam sweeps horizontally. And the horizontal line appears in the middle because X and Y plates have no connection. So now we are giving Y input of about 5 volt DC. We'll start with DC voltage. So the line which was in the middle of the screen now is shifted to 5th block. Why 5th block? Because the Y gain setting, the unit of Y gain setting is volt per division or volt per centimeter. It is 1 volt per centimeter. And input is 5 volt. So 1, 2, 3, 4, 5. So each block is representing 1 volt now. So 5 volt means the line will appear at the end of the 5th block. So if I change the setting for the same voltage, that is 5 volt DC, what will happen? Let us see. The line is shifted to the first block. Now 1 centimeter is representing 5 volt. So the line is shifted to first block. And this is 5 volt. The voltage input is same, but the setting is changed. Now let us change it further. It was changed from 1 to 5. Now let us change from 5 to 2. So what has happened? 1, 2, and it is in the middle of the third block. So 5, 2, 2, 4, and 1, 5. So 5 volt are shown by the screen, but at different position. This has happened due to the change in the setting. And this was all about the DC voltage. And what will happen when we change the supply into AC? So what will happen as a result? The wave is seen because the time base is on. If time base is not on, vertical line will be seen on the screen. So this is the waveform of the AC input. And what is the setting? 50 volt. It means 1 centimeter is representing 50 volt. So it means voltage of this supply is 50 volt AC. And this is the height. Same will be there for the negative peak. For the 10 volt, same AC input, 50 volt AC, Now one block is representing 10 volt. So 50 volt will be shown by 5 blocks. So 1, 2, 3, 4, 5. So appearance of the trace has changed due to the change in setting. Here we have studied both AC and DC. So what will happen to the appearance of the trace when the setting is changed for the same input? First we discussed with the DC voltage of 5 volt, then 50 volt AC. Now frequency and time based setting. So what happens to the appearance of the trace when the time based setting is changed? Unit of time based setting is millisecond per centimeter or microsecond, depending on which setting is chosen, that is time per division or per centimeter. So first, let us turn the time base on so that we can see the waveform. In order to measure the frequency, the appearance should be in the form of wave. So time base is on and time base setting is right now 10 millisecond. It means one division, 1 centimeter is 10 millisecond. And input which is connected to CRO is 10 volt and 50 hertz. The frequency of that voltage is 50 hertz. So what will be the time period? Let us see. So this is the appearance, and with 10 milliseconds per centimeter, one wave is occupying 2 blocks. So this is one wave, the time period 10 plus 10, 20 milliseconds. So we can calculate the time period from the frequency by using the formula T is equal to 1 over F. So that comes equal to 20 milliseconds. So if we change the setting for the same input, the waveform will change. Right now, how many waves we can see? 1, 2, 3, 4, and 5 waves are seen because each wave is occupying 2 block, which is of 10 millisecond each. The time is 10 millisecond for each division. So 50 hertz, 20 millisecond is the time period. So 2 blocks are occupied by each wave. Now let us change the setting. Now 5 milliseconds per centimeter. So the input is same. This is 50 hertz, 20 millisecond time period. So the time period is not changed, but the appearance of the trace has changed. Now it is occupying 4 blocks and number of waves is also decreased. Earlier in the when we had the setting of 10 millisecond per centimeter, there were 5 waves. Now the number of waves are decreased. For 5 millisecond per centimeter, there are 2.5 waves. So one wave is occupying 4 blocks. Each block is 5 millisecond. Each block is representing horizontally 5 milliseconds. So 5, 10, 15, and 20. So time of one wave is 20 milliseconds. So that time is not changed. It is same, but the setting is changed. So appearance of the trace has also changed. Now let us change it to some other value. Oh, 1 millisecond. So we can't get a wave, complete wave. We get only a half wave. Half wave means only the crest we are getting. We could get trough as well. So 1 millisecond, because the time period is 20 milliseconds and now half wave is occupying 10 squares because 1 square is 1 millisecond. So 10 squares will be 10 millisecond and time of half wave is also 10 millisecond. So we can't get a complete wave with this setting. So in order to get a complete wave, yes, this is one complete wave and it is showing the time of 20 milliseconds. How? Because each block is now representing 2 milliseconds. It is equal to 2 milliseconds. So 1, 2, 3, 4, 5. 5 to the 10, time of half wave. 1, 2, 3, 4, 5. 10 milliseconds. 10 plus 10, 20. Okay, so the appearance of the trace has changed just because of change in setting. The input is not changed, that is same, that is 10 volt, 50 hertz, time period 20 millisecond, but the time base setting changes, so appearance of the trace changes. When we decrease the time base setting, number of waves appearing on the screen also decreases. Now, intensity control and positioning. In the previous video, I will include the link in the description box. We studied about the diagram of CRO and basic functioning, how the electrons are emitted from the cathode by means of heating it. So when we heat up the cathode by means of a filament, what happens? The electrons are ejected out and they form a cloud. And these electrons are made to accelerate towards the screen by giving positive potential to anode with respect to cathode. In between, which was not shown in the previous video, that is the grid. Its potential is made slightly negative, and that can be varied, because negative potential will repel high electrons. It will not let the electrons move forward easily. Only high energy electrons will be able to move forward. So right now we haven't given any potential to grid, and the anode is at positive potential and cathode is at negative potential. So electrons are made to accelerate, and we see a bright spot in the middle of the screen because no connections are given to X or Y plate. So spot is appearing exactly in the middle. So if we want to decrease the brightness, because too much bright light may damage the screen, so we can decrease the intensity of CRO, trace of the CRO, by increasing the negative potential of the grid. When the grid is made negative, see that less number of electrons, only those which have high energy, can accelerate towards the screen, and the brightness also decreases. You can compare the brightness with the previous one, that was more brighter because more electrons were hitting, and this can be adjusted by the brightness control knob. We can see it again. When we adjust the brightness control, the electrons which are hitting the screen is less. Number of electrons which are hitting the screen is less, and the brightness is also less. We can go back to the same brightness by readjusting it, and the spot becomes brighter. So more electrons will be hitting. Now, the adjustment or positioning of the bright spot. Sometimes when we turn the CRO on, the spot is not exactly in the middle. So that can be brought to middle by adjusting Y shift and X shift. So since it is not in the origin or not in the middle of the screen, and it is slightly above the x-axis, in the same way it is towards the right of the y-axis. So it means we have to use both the knobs, Y shift knob and X shift knob, in order to bring the spot to the middle. Let us see. First we adjust the position with respect to y-axis. So now it has come to x-axis by adjusting Y shift knob. Now in order to bring it towards the origin, towards the center, because now it has to move along x-axis, so X shift knob will do the job. Now the spot has come in the middle. So wherever the spot is, it can be brought to the middle position by adjusting Y shift or X shift. This can be done with the waves as well. Not only the spot, waves or horizontal lines or vertical line can be brought in the middle by adjusting X shift and Y shift. So that's all, and thank you for watching.